Now that you have already learned how to prepare soluble salts, let us go to insoluble salts. Insoluble salts are prepared using double decomposition or precipitation reactions. Now, let me just recap on something that we did while you're still in Form 1. When you're in Form 1, there is a time we learned about the competition for oxygen. We learned that some metals react more vigorously with oxygen than others. More so, some metals can remove combined oxygen from other metals. That was an example of a decomposition reaction. It was a displacement reaction where one metal displaces oxygen from another. In this case, we advanced the same procedure, but this time, instead of using a metal and a salt, we now use two salts. So let us go right in. Preparation of solid lead sulfate from lead nitrate and potassium sulfate. Now remember, these are solids. The first step is to add about 25 milliliters of water to solid lead to nitrate and solid potassium sulfate in separate beakers and stir with a glass rod to dissolve all the solid. This one will lead us to two solutions, one solution for lead to nitrate and another for potassium sulfate. The next procedure is to add lead to nitrate solution to potassium sulfate solution and stir with a glass rod. You will notice that a white precipitate will be formed. That white precipitate is lead sulfate. That precipitate is filtered off from the mixture and obtained as a residue, and finally we dry the solid between filter papers. Now the reason why this is called a double decomposition can be understood by looking at the equation. Now when you look at this equation, lead nitrate reacts with potassium sulfate and something interesting occurs. The metals exchange the radicals. Lead, which contained the nitrate, now contains the sulfate. Potassium, which contained the sulfate, now contains the nitrate. They have exchanged the radicals. And this process where two salts exchange their radicals in solution is known as double decomposition or precipitation. Now there's something else we need to learn from this. It is known as writing ionic equations. An ionic equations only considers the active part that is taking place. The first thing we do is to split the aqueous solutions into their respective ions. For example, lead nitrate solution contains lead 2 ions and nitrate ions. Potassium sulfate solution, on the other hand, contains potassium ions and sulfate ions. Now, when we get to the solid, we cannot split it because it is not in aqueous solution. We only split the compounds that are in aqueous solution. Then, potassium nitrate contains potassium ions and nitrate ions. When you look at this equation, we have ions that appear on both sides. For example, nitrate ions appear on both sides of the reaction. Again, potassium ions appear on both sides of the equation. These are called spectator ions because they don't take part in the active formation of lead sulfate. And hence, we cross them out as follows. Cross the nitrate, cross out the potassium ions, and we are left with an ionic equation. Lead ions reacting with sulfate ions to give lead sulfate. And the final equation is written as follows. It requires quite some practice for you to get it, but don't worry, you can always repeat the procedure as many times as you wish until you get the hang of it. Again, other salts that can be prepared using double decomposition or precipitation reactions include barium sulfate. See, it is an insoluble salt. Once you realize that you're preparing an insoluble salt, you first of all just think about double decomposition. In this case, we will use two solutions of barium nitrate and sodium sulfate. Remember, if these two salts are given in solid state, we will have to dissolve them in water before we can carry out double decomposition. It is also important to note that the two salts that are used in the preparation must be soluble in water. So the reactants must be soluble in water for this reaction to take place, so that the ions can be split in water. The process of splitting an ion in water is called dissociation. So the ions will be dissociated in water, and therefore they are able to move about and reorganize themselves to form the products. The ionic equation of this reaction is written as follows. And again, another salt that can be prepared using this method is lead 2 iodide. This is a spectacular reaction, like the one, remember the one I told you about golden rain in the beginning of this chapter? Yes, that was the preparation of lead 2 iodide. Lead 2 iodide is yellow in color, and that is why we call it gold rain or golden rain. So you see, precipitation reaction means rain, and then yellow is the color of gold, so it is gold and rain. The ionic equation is as follows. There are many other ways or many other salts that can be prepared using this method, so long as remember that we must be forming an insoluble salt. And this insoluble salt must be formed from two soluble salts. Well, that's it.